Good afternoon, everybody. Welcome to another afternoon, cold but nice afternoon of Chem 170 Organic Chemistry with your host, me, Dr. White. And today we're going to get back to amines. Remember, Dr. White has, see that spot in my heart for amines and especially really look quaternary ammonium salts. And I'm getting all my bad April Fool's jokes out. You're lucky. If April Fool was today, April 1st, you'd be hearing all afternoon all the worst April Fool's jokes you could ever imagine. And they are pretty bad. But you luck out. I'm not going to do any. But all right, today we're going to get back to amines and quaternary ammonium salts, and we should get into amides coming attraction today. I should get to it. I will talk about the dumbest thing I've ever done. And luckily, because I'm an organic chemist, I was able to get out of that situation I put myself in, which was quite dumb, painful, and dumb. And I'll talk about that. And it involves organic chemistry, so that's why I'm bringing it up. And then afterward, we'll do our lab to catch up. I don't know why this semester I'm running just a little behind, but I should be able to catch up today. Anybody look at a bottle of ketchup and see it's got vinegar, which is acetic acid, which is a carboxylic acid? Remember, organic chemistry is all around you. I stole that from SpongeBob. And it won't hurt for you to think about it when you're not in my class. Now you know I'm an organic chemist. And by the way, if you don't like ketchup, you can always look at mustard or relish or pickles. They all have vinegar, acetic acid, which is, guess what? A carboxylic acid. All right, let's get to work. Let's get to the right part of work. All right, I was talking about how to make amines. Everybody see the page? Thank you. All right, now we did the first one on Monday right here, and this should be NH3. And now let's look at the second one. And these are all predicated on the fact that nitrogen has non-bonding pairs of electrons that are nucleophilic. They're looking for anything with a slight positive charge, and the carbon bonded to an halogen has a slight positive charge, and you have what we call nucleophilic substitution, or also called nucleophilic attack. Organic chemists are really violent. And you eliminate HX and you form a primary amine. Now, if you have a primary amine, you can do a similar reaction. And here we have a primary amine, that's shorthand for primary, and it's an amine. And we have an alkyl halide. Notice I'm using R prime. That just tells you like X and Y, R and R prime can be the same or they can be different. And since this reaction generates hydrochloric acid or hydrohalogen acid, we put a base in there to neutralize it. And I'll explain a little more detail later today. I should get to why you don't want any acid around when you have amines present. And what this does is this attacks the carbon with the halogen. Remember, amines, nitrogen have 3 bonds to it. So I have two, one more, I add a hydrogen, and the base neutralizes. You lose this hydrogen from here, this halogen, and you form a secondary amine. Usually you use a very weak base like sodium carbonate. And the question is, what's the organic product or product for the following? Remember, organic chemists don't care about inorganic stuff, which you do make in this reaction. And how do we know? Well, you have to identify what's different, or another way of saying, what functional groups are we dealing with here? Ooh, a nitrogen with a carbon on it, it's a primary amine. Carbon, carbon. Ooh, halogen with a carbon, alkyl halide. And the carbons attached to nitrogen are different than the carbons attached to the iodine. So that's why I'm using R prime base. You have nucleophilic attack on the carbon with the halogen. You lose a proton and a halogen, you form a secondary amine. I'll never ask on a test what's primary, secondary, tertiary. So this is my R. This is my R prime. And therefore, I have my R group, nitrogen. Notice the center carbon of the R prime has the halogen. So that's the one bonded to my nitrogen. And nitrogen has 3 bonds to it. And that's why I put the hydrogen there. And that's how you make secondary amines. And as I mentioned, I worked for a company that made amines for many years. I was their research and development manager for amines in North America, which was a lot of fun. All right, I better share the fun. And I am. Here's one for you to have fun with. Enjoy. I see one person done. We'll do thumbs up. Maybe I'll sneak in a poll, a Zoom poll, but not now. Yeah, I think everybody's just about done. I'm seeing all these thumbs up, so I better get to work. All right, look for what's different, what's not carbon, what's not hydrogen. That's where the fun is. Nitrogen, carbons attached to it. This is a primary amine. Carbon, ooh, halogen, alkyl halide. Remember X can, yeah, come on, X, I'll get it eventually. X can be chlorine, bromine, or iodine. I think I'm having a bad X day. Any X-Men around to help out? Never mind. And in the presence of base, this attacks the carbon with the halogen, and you form a secondary amine. Now, in this case, here's my R, here's my R prime. Oh, hold on. One of my software utilities popped up a little thing. You should get rid of these unused files. And this is what you get, cyclohexyl ethylamine. And oh, let's do one more. But before that, I forgot to mention a couple things. One, good news, Monday night, guess who popped into my office hours? Our classmate, Tim. And he still was in the hospital, but he was a lot better, calling right from his, right after coming out of surgery. He was pretty out of it. But good news, he's doing well. And he called, like I said, Monday night, he called me and I talked to him. And I can't remember the other thing I was going to talk about. Well, when I do, I will talk about it. But anyways, I wanted you to bring you up to date on that. All right, let's have some real fun. And the real fun of organic chemistry, but I'm biased, is synthesis. Remember, I'm a synthetic organic chemist. And what two compounds would you react in the presence of base to give this molecule? And remember, if you can, turn on your webcams, because that way I know there are real faces and people behind the names I see on the screen. And that helps Dr. White be enthusiastic, even though I am normally trying to be enthusiastic. And I think I succeed most of the time. Now, one dilemma you might be asking yourself is, which X do I use, chlorine, bromine, or iodine? And the way I have the problem written, you can use any one of those three. Again, you can use any one of the three halogens. By the way, Dr. White's prior sort of hooked on chlorine, mainly because it's cheaper. All right, thumbs up, people. Oh, I see another face. Thank you. All right, it looks like everybody's done. Oh, I now remember the other thing I was going to bring up, and I'll bring it up after this reaction. And the question is, how do you make this compound? And you look at it, what's different? Ooh, nitrogen with carbons on each side. It's a secondary amine. And what do you react with base to make a secondary amine? A primary amine plus an alkyl halide, where X can be chlorine, bromine, or iodine. And now I can say that's R, and that's R prime. Remember, the halogen on R prime is on the carbon bonded to the nitrogen or vice versa. So if I do this, R is methyl, and it's a primary amine, plus R prime, notice the nitrogen is bonded to the N carbon, so therefore the N carbon will have, like I said, I'm partial to chlorine. And that's how you do it. But wait, what if I say this is really R prime and this is R? And you can. And therefore R, the carbon with the nitrogen, still the carbon with the nitrogen, and then this carbon has my halogen, and that would be the answer if you went, this is R prime and this is R. So the question is, which is correct? And the answer is both of them are. Now, what most of the faculty at either school I teach at wouldn't be able to do, but I have because I've had many decades of experience, I would go with the blue route, only because I know those are probably cheaper to buy, meaning less expensive than the black right here. But on a test, and plus, like I said, most of the faculty at both schools teaching organic wouldn't be able to do what I just said. And I don't expect you to know cost accounting either. Either one would be right on a test. Oh, I see another face. Thank you for turning in. Ah, Dr. White's all happy. Thank you, everybody. All right, let's move on. Now, it turns out that as long as you have, ooh, come on, get back to black. As long as you have non-bonding electrons on nitrogen, you can have nucleophilic attack. And therefore, if you start with a secondary amine, you can make a tertiary amine by the same reaction. And let's take a look at that. Secondary amine plus an alkyl halide. Again, now I'm using double prime. That's like X, Y, and Z in math. And all this tells you they can be the same or different amount of carbons. And again, the non-bonding pair of electrons, which I won't show these on a test, but I can do it easily here. It doesn't matter which side R prime, or double prime R, you get in the presence of tertiary amine. And let's take a look at this reaction. Remember, unlike carbons, we can do this, which tells you there are two methyl groups both attached to that nitrogen. So this is a secondary amine. In this case, R and R prime are both methyl. And here we have an alkyl halide, where X can be chlorine, bromine, or iodine. And what you get is a tertiary amine. So here's my R double prime. We've already identified R and R prime, and therefore I can write this molecule this way. And if you notice, no hydrogens. Why? Because in amines, there's only 3 bonds to nitrogen, not carbon. We're talking about nitrogen. There's still always 4 bonds to carbon. And this has 2 plus 1, 3. And that's how you do it. And why don't you try this one for your fun enjoyment on this still winter-ish, highlight that winter-ish, is that a word in the dictionary, Wednesday afternoon. One of these days, maybe everybody might want to turn on their webcam. For those of you who have, thank you. And go peek into your houses. You can see mine. I'm in my office, otherwise known as bedroom number 3. I have a 3-bedroom house. Very nice. That must be, I've been here since 98. Wow. That's almost as long as some of you have been alive. I shouldn't have said that. Now it makes me feel old. Actually, teaching this keeps me nice and young because I'm surrounded by a lot of nice people. Thank you. All right, thumbs up, people. If you're done, give me a thumbs up. Oh my God, I saw 3 real. All right, we're all done. I better get to work. Now, let's look at this molecule. What's different? What's not carbon? What's not hydrogen? Ooh, and nitrogen. It's got 2 alkyl groups, a cyclohexane ring and a methyl. And we'll call that a secondary amine. What's, ooh, a halogen on a carbon alkyl halide. And if you react that, what do you get? A tertiary amine and therefore I can call this R or R prime. This I can call R prime or R. Here's my R. Oops, this should have been a double prime. Double prime. Watch out, keep an eye on me and my primes. Therefore, I have on nitrogen R, and then I have 2 methyl groups, R prime, R double prime, and you could also write it like this. This would be perfectly correct on a test, but organic chemists are lazy. And this would be another one. Now, one of the things I remembered, plus another thing I can talk about also is, first of all, think about how much you've learned in our time together. 6-8 months ago, would you know what I'm talking about when I say carbons, methyl, or now you know about ketones, carboxylic acids, alcohols, and you're learning about amines, and you'll learn about quaternary ammonium salts. Think about how much you've learned and how it exists in your daily life. Doesn't that feel good? It should. Now, the other thing I'm doing more and more, because we're getting into stuff I can do more and more, is the question, why are you learning this stuff? Well, the obvious answer is someone told you you had to take this class to get into a program or a school. But why learn this? Let's go back and look at the reaction you just did. Everybody see the reaction you just did? Good, thank you. Now, if we look at what you made this tertiary amine. Now, it turns out this tertiary amine is made by a company. It used to be Air Products. I don't know if they've been sold or bought out. And it has a trade name, not the IUPAC, not a common, but a trade name. A trade name is a name a company gives a product of theirs that's an organic molecule. This is called polycat 8. and it's been around since I used it back in the mid-'80s. It's been around a long time. And polycat 8 is a catalyst. What is a catalyst? It's something that makes a reaction go faster. But why do they call it polycat 8? Well, 8, if you count, it has 8 carbons, and it's used as a polymerization catalyst to make urethane foam. If you like getting into your car and sitting on the seat, and it's not like a piece of wood or metal, you're sitting on some urethane foam, and that's made using that catalyst. If you like the fact, and look in your kitchen, or if you're not at home, next time in someone else's kitchen, look at the refrigerator walls. They're thin. If you go back and look at refrigerators from 1950s or 60s, they're like real thick. And the box inside where you put your food was smaller because the walls had to be so thick. Why? And I'll teach you more about it later on. There's an insulator, and the insulator is urethane foam, a different type, not soft like when you sit on furniture at home or your car seat. This is rigid, like I just knocked on my desk. Well, is that rigid? Yeah, it's sometimes rigid and solid. And so excellent insulator. So you can use a lot less than what they did in the 50s and 60s, which was glass wool. How many of you have ever seen those Pink Panther commercials for the insulation? I don't know, they haven't been on for a while. But anyways, those are all made, the urethane foams, with polycat 8. And you just learned how to make that important product. Isn't that cool? It is. All right, let's do one more of these because they're fun. Oh, let's have fun with amines. Oh, time's flying by. You really do have fun. Time flies when you're having fun with amines and Dr. White. Keeping an eye out for my thumbs up, people, when you're done. Oh, wait, I threatened I was going to use it, so I better use it. Aren't you glad Dr. White is a Zen Zoom master? I just came out. I'm just inventing new phrases left and right. You guys have your safety glasses on so you don't get hurt when I'm doing this. I apologize. It's evolving into totally awful humor Wednesday afternoon. All right, everybody done? All right, I think so. Let's do it. All right, question is, what's the organic product or products from following reaction? What's different? Ooh, nitrogen with 2 alkyl groups. This is a secondary amine. Remember, this is how you write 2 of the same on, and I call one R, the other R prime, doesn't matter which side is which. And then, ooh, a ring methyl group, but a carbon with a halogen, and that's an alkyl halide. And we have nucleophilic substitution, nucleophilic attack on the carbon, and you form a tertiary amine. And I'll call this R and R prime. And this whole thing right here is R double prime. And therefore, what do? I have my two methyl groups, R and R prime on the nitrogen, and my R double prime is a 5-membered ring with a methyl group. Remember, this carbon here was this carbon right there, and that's the product. And that's how you do it. And relax if you're trying. By the way, this is not one of my better ones. Doesn't look as nice as mine. As long as I can make it out, it's good on the test. Now, if you notice, the important thing is having a pair of non-bonding electrons that can attack an carbon and an alkyl halide. Alkyl meaning R group, halide, halogen. Well, guess what? You can still do that. And you can do the following reaction. Warning, warning, this reaction is very, very near and dear to my heart because it helped pay my mortgage, a couple of cars, and a whole lot of other things and got me around the world. Because the company I work for, this is how we made most of our quaternary ammonium salts. So guess what? I'm a world authority in this in this reaction. Let's take a look at it. Hint, you should know this one because it's near and dear to my heart. Ooh, triple prime. Remember, this is like WXYZ in math. Take a tertiary amine, react it with an alkyl halide in the presence of base, and what you get, and Dr. White's really feeling happy now because I can talk about quaternary ammonium salts, which I only have about 9 patents in, so I might know a little about it. And let's take a look at one. Now, R sub T means talloalkyl, which means a long chain with 16 to 18 carbons, and there can or cannot have a double bond in it. Some do, some don't. It's a mixture. And then I'm going to react it with this compound. And what do we have here? A tertiary amine. What's different? Nitrogen, alkyl halide. Remember, X can be equal to chlorine, bromine, or iodine. And remember, this attacks and bonds to the carbon with the halogen. Now, what's different is in this reaction, nitrogen is providing both electrons here. Therefore, when you end up, it will have a positive charge. And you'll need an anion. Now, Dr. White always puts his charges, you don't. So I can say the two tallow groups, talloalkyl, it's also called tallow groups, R and R prime, and the methyl group is R double prime, and this methyl group is R triple prime. And one way I could write it would be notice I have one, now I have two, and my anion comes from here, and that's chloride. And another way, and I'm running out of room here, so I'm going to scroll down a little and move me over here. Another way of writing this would be, that's weird, stay up there. Two sides have R sub T, two sides have methyl. And why this is near and dear to me is the fact that this compound, dimethyl ammonium chloride, till about 10, 12 years ago, was the only molecule used as a fabric softener, like in Downy and Snuggle. And I worked for a company that made about half of this molecule worldwide for all the fabric softeners, maybe about 60% of the market. We had a competitor who made the other 40%. Now, do I have time? I do. One of the worst periods of my life in the chemical industry due to chemistry was with that reaction. Our largest customer was Procter & Gamble for Downy fabric softener. And one day I get a call from the vice president of marketing and sales and says, we got a problem. I said, what's the problem? Tell me. Because part of my job was solve problems with products that we made. That was under my jurisdiction, so to say, as a research manager. And quaternary ammonium salts were mine. So anyways, the VP of marketing and sales said, I just got a frantic call from Procter & Gamble people. They're doing a new formulation of Downy, and our quaternary ammonium salt makes their compound, their products stink. What? Doesn't make any sense. Well, they won't be buying from us if we don't fix it. And that was almost $100 million a year in sales. That's a lot of moolah, if you know what I mean. You should. That's a lot. So anyways, I went to work and I started, ours doesn't smell any different. And the salesman who was for that territory at Procter & Gamble called me up. And all of a sudden I started getting calls when I got in the office, before I went to lunch, or I ate lunch in my office, and before I left, from the president of the United States, the company I was with, have you solved it? And I didn't like getting those calls. I told them the truth, no. Well, after a couple of weeks of banging our head against the wall and finding out if you set up a odor panel, can't have anybody who smoked. Unfortunately, I did at the time. Luckily, I gave it up by 86. I'd given up, thank God, but I was a heavy smoker. And you can't have women who are pregnant because that affects their nose. And there's a whole list of things. And we couldn't tell a difference. So finally, I called up the VP of marketing and sales and I said, look, I'm not getting the whole, somehow I figured out, I'm not getting the whole picture. I need to talk to someone at Procter & Gamble who's raising this alarm. Our product stinks, makes their product stinks. Well, it turned out that wasn't that easy. And here's why. At that time, I don't know about today, but at that time, Procter & Gamble had 5 senior perfumers. And their job was, what a product smelled like yesterday, it will smell the same way today, and it will smell the same way tomorrow. And the only way they did that was with their nose and their brain. And these 5 senior perfumers were treated beyond royalty, like gods. And it took a day or two, and finally got a call from a senior vice president of Procter & Gamble and said, we're going to allow you to talk to our senior perfumer who's responsible for our home products and Downy. And he said, first of all, do you smoke? And I said, yeah. Well, you can't smoke for 36 hours before you meet them. All right, I'll do that. Next, in the meeting, do not upset him. If you do, we won't buy from you ever again. Woo. So I said, all right, there's my counterpart at your company, Earl Wall. I haven't talked to Dr. Wall in ages, about 10 years now. We used to keep in touch. We went our separate ways. But anyways, I'd like him in a meeting. The vice president said, no, that's how protected, even in their own company, they wouldn't let most people meet these people, interact with them. And I finally convinced them to let me have Earl in the meeting too, because he was my contact at P&G. So I went to the meeting with the salesman. It was us two, and there was a room of senior people who were there just to make sure I don't tick this guy off. And I was very polite, and he was very polite, and he explained what his job was, how he used his nose, and he made something that nobody laughed at. He thought it was a joke, or no, just nobody laughed at, and he wasn't joking. I got that mixed up. He said, you know, yesterday I smelled something so strong it blew out my nose. I should have gone home. And it actually did. So anyways, I asked him, I said, I've been told our product makes your new formulation of Downy stink. Is that true? He said, no. I said, all right, tell me exactly what is the problem. He said, the intensity of the new perfume, and that was their new formulation, is a little less than with your competitor's product. Enough I can tell the difference, and I shouldn't. That's the problem. You got to fix that. Well, now I knew what I was looking for, and turned out at the company I worked for, we had a great guy who was in the analytical department who did our GC work. I sat down with him and said, we got to analyze vapor over our product to see what's different. And he was Chunan Wang, Dr. Wang, great guy, fabulous analytical chemist, saved my butt a couple of times, like this time. And he found the impurity. Turned out it was a chemical, and I can't tell you which. It's still a trade secret. If I tell you, I'm going to have to kill you. No, I won't, but I just can't. And turned out the chemical, our product had 250 parts per million of this byproduct. Our competitor only had 100. And that difference was masking some of the perfume. So I figured out how it was made, and I got it down to 0. I sent a sample since I had a direct line with the perfumer. So I called him up, smell it, and he called back and said, no, now your product, the perfume's too strong. Because they originally made their new formulation out with our product, with our competitors. That's why we're having the problem. I said, all right. And I knew what was causing that impurity, and I adjusted it in the formulation. So we matched 100 ppm like our competitor. And I sent him a sample, and he said, spot on, good. And I got a call from the president, said, thank you. He's not going to call me anymore 3 times a day. And it was a miserable time of my life until I solved it. All right. Let's get back to quaternary ammonium salts. How do you make them? Now, amines will not react with a benzene ring. And have fun. And to all you have your web camera on, thank you. By the way, I just realized I'm throwing some sophisticated chemistry your way. But that's the fun part of chemistry. When you're done, give me a thumbs up. All right, I think everybody's showing me their thumbs, so I better get to work. All right, what do we have here? Well, R sub T, like I said, is just a long carbon chain of 16 or 18 carbons, and it's abbreviated by R sub T. So it's 1 plus 2 more, that's a tertiary amine. And it doesn't matter which you call R and R prime and R double prime. And here, what's, benzene ring, but amines do not react directly with benzene rings. But I have a carbon with a halogen. All this is this, an alkyl halide, where X can be, in this case, it is chlorine, bromine, or iodine. And this right here is my R triple prime. And what do you get? A quaternary ammonium salt. And you don't have to put the charges here, but Dr. White does. It doesn't matter which side R prime, double prime, or triple prime is, because the molecule can rotate. So if I do that, what I have is my R sub T. I have my 2 methyl groups. And then I have my R prime, triple prime. And we have a quaternary, don't forget the anion. And this is what you make. Now, as I said earlier today, why are you learning this stuff? Well, you've heard my answer because somebody told you had to take this course and you want a good grade. But why learn about this stuff? Well, let's look at the quaternary ammonium salt you just made. These are called benzyl quaternary ammonium salts, or they're called benzyl quats if you work in the industry. And when you put this, is called a benzyl group. It's an alkyl group I didn't teach you. And I won't put on a test. CH2 with a benzene ring is a benzyl. And benzyl quaternary ammonium salts are the best antimicrobial quaternary ammonium salts. And these are used extensively in operating rooms to disinfect everything, the walls, the floor, you name it. And I would have a sinking suspicion this is pretty good on COVID-19, because I've read from CDC, because I am expert in quaternary ammonium salts, therefore I wanted to find out that they are excellent in killing on surfaces COVID-19. Now you can't take them because these are toxic. At least this one is, I don't know about others. But if you look in the Pfizer product, besides nRNA, which I'm an organic chemist, I'm not sure what they got there. One of the other components on the ingredients list, actually 2 of them are quaternary ammonium salts in there to help do something, because they don't put it in there for no reason at all. And so why you learn this stuff? Because it's important in our daily life. If I look at the clock, it's time to take our break. Let's come back in 5 minutes, 1:51, and we'll continue with quaternary ammonium salts and other neat stuff. I haven't used this one in a while. It's time to get back to work. I love that. All right, let's get back to work, everybody. All right, I assume everybody's back. Let's get going. We're talking about quaternary ammonium salts. And let's do one more thing. And the question would be, what two things do you react in base to make this molecule? And I'm going to share the fun, let you do that. By the way, that's a true story about Procter & Gamble. Maybe someday I should write a book, Trials and Tribulations of an Organic Chemist. Nah. Fun with organic chemistry, maybe. Oh, by the way, if I look a little round at the corners, I'm undergoing matzo ball overdose. Dr. White loves matzo balls and it's Passover. And plus, I don't know if I told you, if you're a good organic chemist, you're a good cook. Two go together like that. And Dr. White's a good organic chemist. And you can tell I'm a good cook too. I was lucky when I was young, like 4 or 5, my father started saying, "You're going to cook with me?" And I said, "Well, that's fun." And he was a great cook. My mother was a very good cook. He was better. And times it would just be men only in the kitchen. All right, give me a thumbs up when you're done. If we were in the classroom now, I'd be able to look around and then I'd tell everybody, when you're done, look up and smile. I'd see all these smiling faces sometimes. All right, I think, is everybody done? All right, I think so. Let's go ahead. What is this? What's different? Ooh, a nitrogen with 4 alkyl groups, an anion, it has a positive charge. That's a quaternary ammonium salt. Remember, X can be chlorine, in this case it's bromine, or iodine. And how do you make a quaternary ammonium salt? You take a tertiary amine and react it with an alkyl halide. And therefore, oh, they're all the same. So R prime, R double prime, and R triple prime are methyl. So in that case, my tertiary amine is trimethylamine, and my alkyl halide, notice X here is bromine, would be methyl bromide. And that you react in the presence of base would give you tetramethyl ammonium bromide. Now, there's a really neat way of making primary amines. and that's called the reduction of a nitrile. Now, I haven't mentioned it before, and I don't really ask you to learn names, but when you have a multiple bond, like a double or triple bond, and you add hydrogen to each atom of the double bond to make a, or triple bond to make a atom-atom single bond, we call that a reduction. That's also called the hydrogenation. And if you notice here, this is a nitrile. I'll never ask you what is its name. And by the way, nitriles have IUPAC rules how to name them, but I won't. But if you notice, it's a triple bond between carbon and nitrogen, which means it's got 2 pi bonds and 1 sigma bond. And I should have had here excess. Organic chemists don't, but for this class I do. And what you do is you break the pi bond, and each atom of the double bond gets 2 hydrogens. If you notice, this is a primary amine. And this is an excellent way. I'll explain why Dr. White's real happy now, but let's take a look at an example. And if you look up here, what do we have? What's different? Ooh, what's not carbon? What's not hydrogen? What's not a carbon-carbon single bond? Right here, nitrogen triple bond to carbon. That's a nitrile. I'm reacting it with excess hydrogen. And nickel is a cat. Remember, catalyst can be nickel, platinum, or palladium. And you break the pi bond, 2 of them, and each atom, of the carbon-nitrogen triple bond gets 2 hydrogens. And notice here, this is a primary amine, which I could have also written like this. Three lines in math means identical. So what's my R group? Methyl. Do you break carbon-carbon single bonds? No. Therefore, I have my 3 carbons, but I do break the 2 pi bonds. And each atom of the triple bond gets 2 hydrogens. And I make N-propylamine. I could have written this as CH2, NH2. Either way works for me on a test. And that's how you make a primary amine. Everybody got this down? Remember, Dr. White has the fastest mouse wheel finger this side or the other side of the Mississippi River. If you've never seen the Mississippi River, you're missing something. Maybe that's why they call it Mississippi, because you might be, never mind. Oh, it's awful, awful, terrible humor Wednesday. Sorry. All right, let's do one. And here's one for your fun and enjoyment on this Wednesday afternoon. Now, if it's supposed to warm up like they're saying this weekend, I'll be outside trimming bushes. And don't forget, give me a thumbs up when you're done. I think everybody's done. I got to contact Zoom, have more emojis like this one. All sorts of fun ones. Dr. White can be dangerous. All right, let's do this. What's different? What's not carbon? What's not hydrogen? What's not a carbon-carbon single bond? Well, everything's right there. It's a nitrile, carbon, triple bond to nitrogen. And I've got carbons attached to it, and I'll call this R. I have hydrogen excess. That means you got all the hydrogen in the world that react, anything with hydrogen. I have a catalyst. Catalyst can be nickel, platinum, or palladium. In real life and industry, we use nickel because it's cheaper. And you break the 2 pi bonds, and each atom of the triple bond gets 2 hydrogens. Well, here I have 1, 2, 3, 4, plus this carbon right here, 5. You don't break carbon-carbon single bonds. 1, 2, 3, 4. Here's this carbon, and it's bonded to nitrogen. It'll break the 2 pi bonds. And there's the molecule you get. Pentylamine is one way of saying it. 1-aminopentane would be the IUPAC way. Quick little side note, the reaction you just did when I got hired by AXO as a PhD organic chemist right out of the academic world. I just finished I was postdocing, now I had a real job. And my first research project was that reaction and how to make it work better in existing plant equipment. And I solved it, but at the same time, I thought of a better way and asked my boss, can I work on something else while I'm doing that? He said, sure. And I found a different way of making what was then called short chain amines, less than 10 carbons, and that made me a hero and also led to my first 4 patents. Yay, Dr. White. So that's a very old friend of mine. I thought I'd introduce you. So everybody, say hello to my old friend here that I did research on. All right, let's do one more. All right, and give you, yep, I did give you one. Let's do one more. On test number 3, what would you react with hydrogen and platinum to make this compound? Your turn. On test number 3, I'll either have 3 or 4 synthesis problems like this, give the starting material or materials reactants that would react under those conditions to make the product I give you. In real life, that's what organic chemists do. How do I figure out what can I react to make this compound? I think we'll do this thing to help the company I'm working for sell product, or it will solve a major problem that will help sell product. Ooh, I just forgot. It's something that I just remembered. So as soon as we do this one, I have a special announcement. And don't forget, when you're done, give me a thumbs up. Let's see, I think everybody's done. So I better get to work. All right, question is, what's different? Carbon, ooh, nitrogen. And it's only got one R group. This is a primary amine. And I could also write it this way. And what do we react with hydrogen excess and platinum as a catalyst? Remember, the catalyst can be platinum, palladium, or nickel. You start with a nitrile. And what's my R group? Methyl. Because notice you have R, CH2, NH2. So this is part of that right here. And therefore, if that's the case, that's the nitrile, 2 carbons, 2 carbons. That's how you do it. Now, let's talk about nitrogen. The following won't be on a test, but I just want to remind you, ammonia is a very strong base. What is a base? A proton acceptor. So if you put ammonia in water, you get one of the hydrogen, hydronium ion, or hydrogen cation, hydrogen ions, H plus, transfer over because this is a base and it accepts a proton. That's the word I was looking for. Dr. White just had a brain freeze there for a second. Sorry. But anyways, so ammonia, our bases, is a base, proton acceptor. And if you took general chemistry here, like 112, which I've taught, you would have learned this. Now, let's look at amines. Hold on. Well, I wait till everybody copies down what they want to copy down. I'll never put this reaction on a test. All right, everybody got it? Don't tell anybody I'm being nice and not going ahead while you're not finished. All right, now amines, and I'm going to actually change this, are also bases. Or you can say they're basic. And they will accept the proton. This is hydrochloric acid, a strong acid, and you make an amine salt. If I could spell it right. And this will happen, if you notice I have there, with all amines, quaternary ammonium salts, the non-bonding electrons right here are gone, and that's what makes it a base. So it's just with amines, not quaternary ammonium salts. They're not basic. So, by the way, switch is on for this reaction, so you should know this, but I'm going to rewrite it. Everybody have this? Oh, by the way, tonight at midnight, I'll be giving speed note-taking lessons. No, I won't. All right, let's take a look at this. A better way to write this and it can be any acid, but I'm going to stick to HX, hydrogen halogen. And here R prime and R double prime can be hydrogen, one or both, which means primary, secondary, tertiary amines. This covers it all. X can be here, chlorine, bromine, or iodide. This is a base. We have an acid. We make an amine salt. And here, if we take the following, what do we have? Well, we've got this where our prime and our double prime can be hydrogen. In our case, it is. And when you react it with HX, where X can be chlorine, bromine, or iodine, you get an amine salt. Whatever attached to nitrogen is still there, and you add one hydrogen. This has a charge. You don't have to show them, but I will. And let me, and here's my R group. I can call this R prime and R double prime. Here's my X. React that. Notice I have two hydrogens. I'll add one more, but it's a plus charge, and my anion is chloride. And that's how you make an amine salt. And why don't you try this one for your fun and enjoyment? See what a nice person I am? I think about your fun and enjoyment all the time. Make sure you have some. Organic chemistry, fun and enjoyment. All right, I think everybody's done. Let's take a look at this. What do I have? Ooh, a nitrogen with alkyl groups on it. I have a secondary amine, but it could have been a primary amine or tertiary amine. Why? Because I'm reacting it with acid, HX. And X can be chlorine, bromine, or iodide. And what I make is an amine salt. In this case, I can call this R, I can call that R prime, I can call that R double prime, and therefore that's still attached. I'll add another hydrogen, I will. This now has a charge, but you don't have to put it. And we have a counter ion, in this case, X is bromine. Now, I should point out, just like in quaternary ammonium salts, this is really bonded to the nitrogen by an ionic bond. Everything else is covalent on the nitrogen. And that's how you make amine salts. Now, one of the things I had wanted to wait until now is you should know nomenclature, common nomenclature. UPAC has it, but nobody uses it unless you have to in a legal document. for amine salts. And how do you do that? Remember, our prime and our double prime can be hydrogen. And the nomenclature for amine salts is same as quaternary ammonium salts. And that is one. Name all R groups as alkyl groups in front. 2, add at the end the words ammonium, halide, and remember Cl is chloride, Br minus is bromide, and I minus is iodide. Now, one of the things students always ask me is, well, if you name it the same as a quaternary ammonium salt, how can I tell the difference? Well, quaternary ammonium salt always has 4 R groups named in the front. But a amine salt never has 4. It can have 1, 2, or 3. And what would you name that? That would be methyl. Oops. Gotta finish it. Methyl, and then it's amine salt, so I add ammonium. The halide is iodide. And why don't you try one? And there you go. That's better. Again, what would be the common name for that molecule? Switches on test 3 for nomenclature. I will have give the common or IUPAC name for the following. I see one thumbs up. I see another one that's already been up. I guess you guys are all finished. Let's look at this. What's different? Nitrogen, but it also has an anion. So that's either whenever you see an anion associated with a nitrogen compound, it's either an ammonium salt or a quaternary ammonium salt. And here we only have 2 R groups, and it's common, so it doesn't matter which one you put first, ethyl, methyl, ammonium chloride. And that's how you do it. Now, by putting a charge, making an amine salt, putting a charge on nitrogen, you make it more water soluble. And when we get into surfactants and lipids, I'll talk more about why that's important. It's called making a molecule polar. Now, if you go and look in your medicine cabinet for over-the-counter stuff like cough medicine or other things, or if you have certain prescription drugs and you look at the active ingredient or ingredients, you may see a name, ammonium chloride or something like that, bromide, or you may see a name, something, something, dot, hydrochloride, the words, or HCl. And what happens is drug manufacturers have found out by putting a nitrogen on a molecule and making an amine salt, it's more water soluble when you take it orally in your stomach. And more importantly, it's more water soluble. Can you see my blood veins there? Anyways, more water soluble in your blood veins. I think they're better on here. You can see them. But anyways, that helps get the medicine to the parts of your body it needs to get to. So amine salts are important. All right, couple important things. Listen up real quick. One, on Monday, I will go through the esters, carboxylic acid, and esters problem set. So I highly recommend you do it before Monday. That will help you do good on test number 3. Test number 3 will be like test number 2, about 35 points nomenclature, about 65 or 60 points reactions, and a little general knowledge too. Anybody happen to look at a bottle of vinegar and see it has acetic acid in it? It's a carboxylic acid. That's good general knowledge. All right. Guess what time it is? It's new functional group time. And this new functional group is a derivative, that means made from, the reaction of a carboxylic acid with an amine. And we call them amides. Good news, I'm not going to even teach you any amide nomenclature, but I do want to talk about amides. What's an amide? An amide is where you take the carboxylic acid and replace it with a nitrogen with alkyl groups on it. Now remember, this nitrogen, there are 3 bonds to nitrogen in amides, just like an amine. And that has it. And here we have a carbonyl, and this is called an amide. And when Dr. White was at AXO, we made amides to one of the largest manufacturers of amides in the world. And this is an amide, and you should know this. I won't do nomenclature. Now, the way I have it written, R prime and R double prime can be hydrogen, not only just carbons like you normally see, and one or both can be, and that's an amide. Now, quick thing, when R prime and R double prime are hydrogens, this is an amide also. And this is very long. I worked for a company that made those. And when the R is very long, it's called the rusamide, 22 carbons, including the carbonyl carbon, that's long. It's called an anti-slip product. Now, if you've ever gone to the supermarket in the produce section, you know how they have those bags on the rolls you put your produce in if you're picking your own. Have you ever picked up one or pulled one off the roll and you try and open it and you can't open it up? Well, it turns out plastic, if you don't put a certain chemical in, stays stick together by what's called van der Waals forces. And it's impossible almost to pull it apart. By putting an amide in there, rusamide, it helps make it slip apart, and they're called slippery agents. And whenever I go to the supermarket, if I take a roll bag off the roll and I can't open it up, I immediately know the company that made that was cheap and they didn't put enough amide in there. And the main one is a rusamide. And take that bag, throw it in a garbage can nearby, and go to another roll because you're going to waste your time trying to get it separated. All right, that's amides. Now, why are you learning about organic chemistry? Well, I'm going to skip this slide, primary, secondary, should have taken it out. Now, there are cyclic amides, and these are called lactams. Switch is totally off for this. Now, switch is back on. Now, this is a special molecule. Special in the case that here, if you look at it, this is an amide, but here, if I say R prime can be this, urea undergoes all the chemistry amides do, so urea is considered an amide. Now, urea is the major organic molecule or chemical in urine, both human and animal. And this is one way our body has of getting rid of nitrogen waste. The major chemical in urine is obviously water, but this is the major organic. Now, isolated, it's a white solid and has an important role in organic chemistry, industrial organic chemistry. It's used to make certain polymers that are very useful as adhesives, otherwise known as glue. And Dr. White worked at a company, Borden Chemical, where we used the urea and everything. And one of my more fond memories of being in the chemical plant that day, supervising a new reaction of mine using urea was, they come in what's called super sacks. And I'll show you later in the semester some pictures of me in a chemical plant. I'm not supposed to, but anyways, and super sack is 2,000 pounds and should be a nice flowing solid, just like salt you have on your, but this was all caked together. So Dr. White and about 9 other workers in the plant, each of us had 20, 30-pound sledgehammers and spent the next hour breaking it apart. Got a good workout, not fun. It was summer too. Boy, did we sweat. But anyways, that's urea. How many of you have ever had hot peppers? How many of you like hot peppers? Now, you know there's jalapeno, and you can get hotter in some of the red peppers, like the Thai chili peppers. Then you can go blazing hot to habaneros and ghost peppers. And it's time for Dr. White to talk about one of the dumbest things I've ever done in my life. But first, let me talk about why are green peppers don't have any, or red peppers, no kick to it. Then you go to habanero, they got a good kick to it. You go to, jalapeno, those have a good kick to it. And then you go to Scotch bonnet and habaneros, and they like, whoa, I'm on fire. Help, get the fire department. They're super hot. What's the difference? The amount of a certain amide in each of the peppers. The more of this amide, the hotter it is. What amide is that? This won't be on a test. That's this one, has the common name capsaicin. Hold on one second. if I forget, turn off proofing. And this is capsaicin. If you notice right here, you have a lot of functional groups in here. Here we have an amide, carbonyl, R group, nitrogen, hydrogen, R prime. And remember, our double prime can be hydrogen. So this is an amide. It also has a benzene ring, has an ether, has an alcohol, and it also has a double bond. There's a lot going on there. Now, why does your body interpret this as hot and blazing hot? I have no idea, but I know it does. And the more in a pepper it is, the hotter it is. Hang in there. Everybody see the Spice House ground habanero? All right. First of all, this is one of the best places in the United States to buy spices. They're located in Chicago and Evanston, but they ship. I don't go to Evanston anymore in the pandemic, but a number of years ago, the Spice House, and by the way, when I used to go there, one time I helped them out with their scales. So I got introduced when I'm there sometimes, or when I was there, you'd run in some of the top chefs in Chicago, because this is where they bought their spices. Well, they came out with a new product called ground habanero. And it's this powder you see here. It comes in these innocent looking little shakers. That's dangerous as heck. It's not cheap, but it goes a long, long time. Now, it's time for Dr. White to talk about one of the stupidest things I've ever done. Well, I've got this new stuff, habanero. I came home and I said, wow, I wonder how hot it is. I went like this and just a little bit on my finger, went like that. Immediately, I was in instant pain. Not hot, pain, bad pain. And not only my tongue, but the insides of my mouth were, oh, it was, and I figure, what do I do? And I'll teach you later on about this. It's called like dissolves like, that's a nonpolar. And one of the things that you do is like dissolve like, water is polar and it won't do anything to help get rid of that pain, which is what's causing that pain is the capsaicin. So I figured, all right, I know like dissolves like, and I'll teach this later when we get into how soap works. But I said, what do I have that's non-polar? And I'm doing like emergency problem solving. I was standing right next to my refrigerator. I pulled out from the refrigerator, grabbed the bottle of mayonnaise, got a spoon, which was right near, like this in my mouth, swished it out, went to the sink with the bottle and the spoon, spit it out, and did it 2 more times. Pain was all gone. But I could have done shots of vegetable oil too, but that was quicker. By the way, mayonnaise, which was what I was using, is half water, half vegetable oil. And that's how, if you've ever heard people at a restaurant, if you eat something hot, they say either drink some milk, milk has fat in it that helps get it out, like the oil in mayonnaise, or eat some bread with butter. And it's really the butter, not the bread, that's getting it out. You could just do shots of pads of butter and swish it out and don't swallow because it's going to go in your. And I learned the hard way. Whenever I cook with that stuff, it's like big pot, think, because it's good. So that's capsaicin. Now, how do you make amides? I'm going to skip this slide because there's a better way of writing it totally here. And if you take a carboxylic acid and amine, you form an amide. Like I said, I work for a company, and this is part of my responsibility. This product lines for amides. And this is why I skipped that one slide. And if you react it with amines, primary, secondary amines, you form an amide. This attacks the carbonyl carbon and you lose water. One of the rare times Dr. White will put down something inorganic. Now remember, R prime and R double prime can be hydrogen. So this also means ammonia, NH3, or primary secondary amines. And let's look at the following. What's the organic product or products of the following reaction? Well, what do I have here? I have a carboxylic acid. I was getting ahead of myself, where this is my R group. Ooh, what's different here? Nitrogen with carbons. I have an amine, which I can write for this reaction like this. And remember, R prime and R double prime, one or both, can be hydrogen. And if I look at this, what do I get? An amide. And therefore, what's our prime methyl? One of these hydrogens is our double prime. Keep your eye on the carbonyl carbon, because that's where the fun is. What's attached to it are, which is a methyl. Then I'll have my nitrogen. One of the R groups are double, R prime is methyl, and the other one is hydrogen, which I'm running out of room, so I'm going to go down here, which you could also write, and I'll bring this down again. Let me move me out of the way. And you can write that. You can write it like this or like this. And that's how you make amides. Like I said, ooh, it's time to scare my students. Hold on, I see people still writing it. Sorry. Y'all done writing? All right. Now, time to scare you right before our next break. And that is, everybody, look at your skin. Touch it. Guess what? These are amides. All your skin, your muscles are amides. Yeah, they're amides. Why are you learning organic chemistry? Ooh, I'll do that again. That's scary. I'm not going to do it again. I'm sorry. Why are you learning organic? Because your skin's organic chemistry. By the way, your hair, what's left of mine, my beard, that's amides too. And with that, all your proteins are amides too. I'm going to say, time for a break. Come back in 5. That means 250. All right, let's get back to work. I'll get you out before midnight today. Ooh, I better use my whistle to get you all back. All right, before the break, I was talking about amides. Like I said, that habanero ground is good, but it's dangerous. You got to be careful with that stuff. All right, we're talking about how do you make an amide? You react the carboxylic acid with either ammonia, NH3, or a primary or secondary amine. And let's take a look here. I'm going to let you have one. And why don't you do the following? What would be the organic product or products for the following reaction? All right, I think everybody's done. Let's do this. What's different here? Oh, we got a carboxylic acid. The oxygens gave it away. Oh, this is ammonia, but I can write it like this. Where R prime and R double prime can be hydrogen. And what do you get? You get an amide. Remember, all fun happens at the carbonyl carbon. You replace the hydroxyl group with an R prime, R double prime. Well, in this case, here's my R group. Oops. Let's do it correctly. Here's my R group. And notice here, R prime and R double prime are hydrogen. So I'm going to have my R group, 2 carbons, carbonyl, nitrogen, and R prime and R double prime are hydrogen, so I can draw it that way. You could put them as single bonds too. And oops, that should be a 2. And that's the amide you get. Oh, let's do another one. And here's one for you to do again. What would be the organic product or products that are following? And we're going to go a little longer than normal on a Wednesday, but I'm trying to catch up. Remember, ketchup has acetic acid and vinegar acetic acid, which is a carboxylic acid. Oh, by the way, amines do not directly react with benzene rings. So think of that as just an R group. All right, looks like everybody's done. Let's take a look at this reaction. What do we have here that's different? Well, benzene ring, but that's not going to react with an amine because this right here, carbon, carbon, nitrogen, that's an amine, where R and R prime are both ethyl. R prime and R double prime. And this, what's that? Carboxylic acid. In this case, that's my R group. React these together. Remember, R prime and R double prime can be hydrogen, but in this case, they're not. And what do I get? An amide. So keep your eye on the carbonyl carbon, because that's where the fun is. And my R group here is a benzene ring with a methyl group 1, 3, or meta. 1, 2, 3. And on my nitrogen, I can draw it this way. My 2 methyl groups, methyl ethyl groups, which are R prime and R double prime. You could have also drawn it this way. Either one would be correct. and that would be the product you get. Remember, I'm doing it more and more, and I'm going to do it again. Why are you learning organic chemistry? Well, you know the obvious answer, because someone said you had to. But why? Well, what's coming up soon in a couple of months? Summer. And what's going to happen if you go outside early in the morning to mow your lawn? You're going to get eaten up unless you put something on your skin to get rid of the mosquitoes, to ward them off, a repellent. And what's the best repellent? It's called DEET. Everybody see DEET on your screen from Wikipedia? DEET is short for N,N-diethylmethylamide, DEET, and it has this structure. Now it's a benzene ring. The end of the line here is a methyl, carbonyl, nitrogen, and these are two ethyl groups. That's the molecule you just made. And that's why you're learning these things, because the general reactions I'm teaching you are used to make many things in your daily life. Now, important, quick Dr. White story. Now, when I first bought this house, first time I went out and mowed the lawn, I got attacked brutally by mosquitoes. Well, I better get to somewhere and buy some repellent. So it just so happens it was convenient, which I only go in there about 4 or 5 times a year, really. But I went to Walmart, and I went to the place where they had all the mosquito repellents, and they had the name brand, which was a smaller bottle and more expensive. And then they had their Walmart brand. I forgot what it's called. And it's bigger and it's cheaper. So I said, I wonder if there's a real difference. So I looked at the labels. Now you can too. And at that time, I knew quite well the active ingredient is DEET, which is, I showed you. Now, the name brand begins with an O and then the letters F and you know what else, had about 2.5% DEET, less, and it costs a lot more. The Walmart was at 4.25 or better. It was twice as much DEET, more of it, and it was cheaper. Well, you know what Dr. White bought? The Walmart, and I've been buying it ever since. It's always been, I always am amazed people who don't know how to read labels and look for active ingredients and know what they are. And I have to remember, I'm an organic chemist, so I know these things, and most people don't. It's obvious which one to buy. The one that has the more DEET, and it's also at the same time cheaper, because you can put less on because it's stronger concentration and it does a better job. If you notice, I haven't been eaten alive by mosquitoes because of that. Uh-oh. Hang on. My computer just told me. Sorry about this. I think I got to buy more memory for my computer because of all the things I've got going on now when I'm teaching. Doesn't do it for my general chemistry, but my computer gets all flustered with all the structures. All right, now let's move on. Once you have an amide, how do you react it? Well, you can have acid hydrolysis of an amide. And here we take an amide. The only acid I'm going to use this semester is HCl, hydrochloric, and water, and you get back the carboxylic acid you would have used to make that amide, but you get the amine salt of the amine you would have used to make that amide. Why does that happen? Well, let's go to my whiteboard. And since you could have other acids, but I'm going to stick to chlorine, so the counter ion is chloride. Well, here's what happens. When you add the HCl and water, and I'm not going to go through all the mechanisms, you get back the carboxylic acid you would have used to make that amide, and you get back the amine. Why don't you write that down, Dr. White? Well, you can isolate it because amines are bases, and if I have any acid around, it will immediately react to give the amine salt, which I just went through an amine to amine salt. And remember, acid-base reactions are the fastest reactions in all of nature. Therefore, you're not going to get an amine. If you write it down, I'll mark it wrong. You get the amine salt. And sometimes, as you know, organic chemists write reactants above and below the arrow. And question is, what's the organic product or the products are the following? And we look at what's different. Ooh, oxygen, double bond to carbon, and a nitrogen on that same carbon. This is an amide. I have an R group, R prime, R double prime. Remember, R prime and R double prime can be hydrogen. In this case, they might be, and reacted with HCl and water. And what you get is the carboxylic acid you would have used to make that amide, plus not the amine, but the amine salt you would have used, the amine salt of the amine you would have used to make that amide. So what's R? What's R prime? What's R double prime? And now keep your eye on the carbonyl carbon. What's attached to it right here? R methyl. So you get that carboxylic acid, and notice R prime is methyl, and R is double prime is hydrogen, and I add two more hydrogens here, plus charge, and the cation, anion, is chloride. And you could have written this as this. And that's acid hydrolysis of an amide. And I'm coming at you strong, a lot and strong today. Why are you learning organic chemistry? You know, the next line I'm going to say, yep, you're right, because someone told you had to take it. But the reaction I just showed you, acid hydrolysis of an amide, is how your body, your stomach, remember there's HCl in there and water, breaks down proteins to amino acids. So why are you learning this? Well, if you like being alive by eating protein, which keeps you nice and strong and healthy, well, that's because of organic chemistry going on in your stomach. I think it's your small or large intestine too, but don't quote me on that. Remember, the last biology I had was freshman year of high school. Not because there's anything wrong with biology, but I already knew I was going to be a chemist then. Yep, back then I did. Even grammar school, I think I already was hooked on chemistry. But anyways, think about it. Next time you eat food and it has any protein in it, you know, the good stuff like a hot dog, hamburger, a steak, or if you're vegetarian, soybeans. Dr. White loves soybeans too. But anyways, after you chew and swallow, it goes into your stomach. You're doing acid hydrolysis of an amide. How many of you have heard of a peptide bond? That's really an amide bond. I'll teach you the right way later on this semester. And for your fun and enjoyment on this overcast Wednesday afternoon, that's cold outside, I'll bet. Let's find out. Have fun. And don't forget, Dr. White's a YouTube star, and you can find all the videos to Chem 170 this semester on the Chem 170 YouTube channel, which is located, you can see, in the syllabus and also on the front homepage of Chem 170 and D2L. All right, don't forget to give me a thumbs up, all my loyal students out there. All right. I think everybody's done. Let's do it. What do we have that's different here? Ooh, carbonyl and a nitrogen to the carbonyl. Remember, carbonyl, I told you, is found in many functional groups. It's in amides too. So we have an amide. And if we react it with acid, HCl, because that's what's in your stomach, that's why I'm using it. You could use other acids. You get back the carboxylic acid you would have used to make that amide, but you get the amine salt of the amine you could have, oops, this should, the amine salt of the amine you would have used to make that amide. And remember, R prime and R double prime can be hydrogen. In this case, they're not. So here is my R group, and notice R prime and R double prime are methyl. So keep your eye on the carbonyl carbon. That's where the fun always is. And my R group is ethyl. And let's make a little room up here. My R prime and R double prime are methyl. And I can write it like this. And I add 2 more hydrogens to make an amine salt. And my anion is like that. You could have also written it this way. Both would be acceptable on test number 3 and the final. And you don't have to put charges, but I like to good habits I don't break. And again, this is a key general reaction, acid hydrolysis of an amide, that your body breaks down protein. And since today's lab day, thank you for letting me go a little extra. I wanted to catch up. Remember, ketchup has vinegar, which has acetic acid, which is a carboxylic acid. I can say that in this chapter. But anyways, guess what time it is? It's laboratory time. And today's laboratory, we're going to be dealing with carboxylic acids and carboxylate anions. And Dr. White's sad because it'd be fun in the lab today. Let me open up that lab. All right. Why can't I open up my labs? All right, there we go. Uh-oh, I better do something. Time out for all right, sorry about all that. I had this modified it earlier today and it was on my other machine that I do work. All right. Everybody see the lab now? Yay. All right. Now, first thing, carboxylic acids have the following structure. Now, carboxylic acids has an oxygen and a hydrogen, so can hydrogen bond to water. And that helps in water solubility. But are there factors that can affect the water solubility of carboxylic acids? Well, in this lab, you're going to find out. And if we were in a lab, you would be doing the following in 4 small test tubes. You fill it up with DI water, means deionized, no ions in the water. And each test tube, you add some of the carboxylic acid to be tested, and then you'd mix it and look if it's soluble or not. If it's the same throughout, homogeneous, fancy word time, then it would be soluble. If you see 2 layers, it's insoluble. And the ones we're using are acetic acid, propanoic acid, stearic acid, and oleic acid. I would like you underneath here, draw the structures, oleic and stearic. You can look it up on with Google. You can see I just did a generation gap thing since I don't use Google ever as a verb. I don't ever say Google it. I don't like that. I'm professional. Nah. Anyways, that's part 1, determining the solubility of carboxylic acids and what factor affects the solubility. And if you notice, I give you the data because we're not in a lab. All right, the next one is a fun reaction, and that's the reaction of carboxylic acids with sodium bicarbonate. Remember the rocket ship story I told you? Where, yep, I see some people smiling. And if you have a carboxylic acid and you react it with sodium bicarbonate, what you get, if you look at all the products, is a carboxylate anion, water, plus CO2 given off as a gas. Now, this is an acid-base reaction. And just to remind you, you can measure the acidity of something, how acidic it is or how basic it is, by using litmus paper, the pH scale. And pH, just to remind you, goes from 0 to 14. 7 is neutral pH. Below 7, it means the solution is acidic. And above 7 is basic. So pH tells you if something's acidic or basic. So in this experiment, you get to work with it. We're in the lab. And again, now Dr. White's very, very sad. Some very dangerous chemicals. And those dangerous chemicals are acetic acid, which in the lab, I tell you that's really vinegar. Then lemon juice, now real dangerous stuff. Tomato paste, that's dangerous because you could stain your clothes, but you can put on gloves and be careful. And stearic acid and oleic acid. And what you would do is to put it in the carboxylic acid in a beaker with water, measure the pH with pH paper. I think you've all used pH paper. It changes color at different pHs. And then add some bicarbonate, sodium bicarbonate. We got a couple cans of baking powder from whatever generic brand Dr. Daly gets, who runs the lab. And then measure the pH and observe what you see. Bubbles, hint. And bubbles, arrow up tells you a gas, and gas in a liquid becomes a bubbles. And here, have fun. And if you want to see it, I have some YouTube videos that you can have fun with. Now, the last part deals with mainly, I should have taken the stearic out of here, just acetic and oleic acid. And it's a reaction with a strong base, sodium hydroxide. And then something else. Now, for this lab, you're going to take two different carboxylic acids, and each one, you're going to react it with enough sodium hydroxide that phenolphthalein changes color, which tells you you've converted the carboxylic acid to this carboxylate anion. And you'll observe, is it water soluble or not? Or what happens? And also measure, just observe it physically. Now, the next reaction I want to show you is the following. Before I do that, how many of you have ever heard of hard water and soft water? And hard water generally means how much of certain ions are present. Luckily, if you get Lake Michigan water, that's not too hard. If you go to certain parts of the country, it's hard. It even has iron in it. And that's why if certain parts, I forgot where it was, out west, if you see people wearing, they don't have special conditioners in their house, when they do their laundry, their white t-shirts and everything have a dingy yellow look to it. And you see rust stains in their sink of their houses, or iron stains, not really rust. But in Chicagoland, mostly it's calcium salts that affect the hardness. If you're above 150 parts per million, that's considered hard water. Well, in this lab, instead of using hard water, I changed, remember I wrote all these, that, and I'm going to balance it because students get mad if I don't. If you take a carboxylate anion and react it with magnesium sulfate, otherwise known as Epsom salt, magnesium is really a +2 cation. And all molecules have a net zero charge, and you form the magnesium salt. And you also make sodium sulfate, which is water soluble. And this is the interesting molecule. Now, what role does R play in solubility? In this lab, you'll find out, but I'm going to sort of give it away. That's the sad thing about it. You can't do it. And what you would do is take the acetic acid, add enough sodium hydroxide to make what's called sodium acetate, this carboxylate anion. And you observe it, and it's clear and homogeneous. You take oleic acid, and oleic is where R is much, much bigger, a lot bigger, and add enough sodium hydroxide, the color changes, so you'll get where R is much larger, and you get that carboxylate anion, and it's still water soluble. Now, to each of these solutions, which is really this right here, you're going to add magnesium sulfate solution, otherwise known as Epsom salt, and observe. And remember, what effect does R have on solubility? Now, the acetic acid, students will ask me, Dr. White, nothing happened. I don't see anything in the Erlenmeyer you do this in. And I said, no, you did it right. It's supposed to be clear. So they write it down. But the oleic acid one, they see this really icky white. How do you like that professional icky? But anyways, I think, does everybody know what icky means? Or is that a generation gap thing? Give me a thumbs up if you know what icky means. Thank you. But, well, you got to watch out. I might use something archaic that you've never heard ever, and your parents may not know. But anyways, it's a white solid. And here's why I had to. Let's go to the internet. Everybody see the beakers on there? Erlenmeyer's not beaker.
Fire like water. So not much effect on the 3 drops of soap solution we added here. Here's the soft water.
Now here we have soft and hard.
Different sound.
And think of the soft before you add the magnesium sulfate and the hard afterward.
For that one. And if we even add another 6 drops of the hard water, we'll just see if we get any more effect.
That's like adding the magnesium sulfate.
Just kind of showing you the savings you're going to get having soft water as opposed to hard water, because your soap solutions are.
You can tell this guy doesn't know chemistry.
You're not getting.
In an Erlenmeyer, you don't shake it with a stopper.
So we got a little bit here, but it slowly dissipates down. In the buildup in your shower. That's where you're seeing the buildup in your shower to that beaker. So
See that right there on the side of the, everybody see this right here on the side? That's soap scum. Yeah, let me recalibrate my jaws. Soap scum. And in the soft water, there's none. Well, in the lab, when you were doing this, you'd see the same thing with the oleic acid or sodium oleate, really, and magnesium sulfate. I'd be going around to each group and say, guess what you made, Erlenmeyer? They'd look, what? Soap scum, you know, that ring around the bathtub? And that's today's lab. And I'll let you. And when we get into good news, coming attractions, when we get into lipids in a couple of weeks, we're getting close to the end of the semester. The semester's about half done. It's really zooming along quick. Zooming along on Zoom. Sorry. But anyways, I even cracked myself up. I'll teach you how. How many of you have ever cleaned out a bathtub or shower stall and it's caked with that scum and it's a real hard task? And you just got to scrub and scrub. And even with scrubbing, unless you get CLR, and I don't like that because I don't know what's in there. I don't like using stuff I don't know what's in there. But anyways, I'll teach you how to use a product that's cheap. You can get it at any supermarket. And actual scrubbing time is about 3 or 4 minutes and not even that much scrubbing even then. And you got to wait about 10 minutes in between. So within 15, 20 minutes with very little work, you can get a totally yucked up. Ooh, it's another fancy word, Dr. You. Everybody know what yucked up means? What yucky? Icky. My good friends, icky and yucky. I better let you guys go. I need a reboot. It's all those matzo balls. See what it does to you in matzo? No, I'm just kidding. But anyways, I'll teach you how to do that. And with that, let's take a look at the lab once more. I've given you the observation white solid. That's really bathtub scum. You can go back and watch this again if you like. And there's your questions to do. And this is due next Wednesday. So with that, I'm going to do my famous goodbye. Goodbye, King Gesund. Have a nice rest of the week. I'll see you on Monday. For those of you who celebrate Easter, happy Easter. I hope you get the bunny you want, the big chocolate one. Or for those, or you get the nice eggs. I don't celebrate Easter, even though I know about chocolate eggs and bunnies. Chocolate bunnies, good. But anyways, not during Passover, because I'm celebrating Passover. Those of you who are celebrating Passover, happy Passover. Those of you who do neither, happy rest of the day and rest of the week. And I'll see you on Monday. Gang gesund, be healthy. I'll see you on Monday. Bye.